By the end of this lesson, the students will be able to distinguish between reversible and non-reversible reactions, define the term chemical equilibrium, click the Add button to add 6 grams of magnesium to 125 cubic centimeter of 2 mole per cubic decimeter of HCl in a beaker. Click on the solution in the beaker to view the particles present. In this reaction, there is a complete conversion of reactants to products. Reactions that go to completion are said to be non-reversible. Such reactions continue until one of the reactants is used up. The reaction A gives B is a non-reversible reaction. Drag the slider to view the change in concentration of both the reactant and product. Let us look at the reaction between hydrogen and iodine to form hydrogen iodide. Click on the valve to open it and allow the two reactants to mix. Why does the color of the gas in the container become lighter and lighter? Click on the Show button to view the particles present in the gas at different time intervals. Answer: the concentration of iodine decreases as it reacts with hydrogen to form colorless hydrogen iodide. Click the Clear button. The color of the gas in the flask now stops changing. The reaction appears to have stopped. Click on the Show button to view the particles present. What is the gas in the flask made up of? Answer: the gas in the container is made up of a mixture of hydrogen, iodine, and hydrogen iodide. The reaction between hydrogen and iodine does not go to completion. This is because hydrogen iodide, the product of the reaction between hydrogen and iodine, can dissociate to form the original reactants. A chemical reaction that can take place in both directions is called a reversible reaction. Summary: a reaction that goes to completion is said to be non-reversible. A reversible reaction is one that can take place in both directions. The products of the reaction can react back to form the original reactants. Let us now look at how the concentrations of hydrogen, iodine, and hydrogen iodide change with time. Drag the slider to the right and note the change in the heights of the bars. What do you notice about the change in the concentrations of the reactants and products? Answer: the concentrations of both the reactants and products remain unchanged after some time. When this happens, the reaction is said to have reached a state of chemical equilibrium. The mixture of reactants and products at this state is called an equilibrium mixture. What is the composition of the equilibrium mixture for this reaction? Answer: 0.2 mole of H2, 0.2 mole of I2, and 1.6 mole of HI. Click the Graph button to view the change in concentrations of the reactants and products in a graphical form. Drag the slider to the point at which the reaction reaches a state of chemical equilibrium. The flask contains an equilibrium mixture of hydrogen iodine and hydrogen iodide. We cannot determine from the color of the gas whether the reactions are still going on at this stage. We can, however, use radioactive tracers to find out. Click on the valve to add some radioactive iodine 131. Note that the pressure is maintained at the same level. The equilibrium mixture is analyzed and radioactive iodine 131 is found to be present in some hydrogen iodide molecules. What can you deduce from this observation? Answer: the synthesis of hydrogen iodide and the decomposition of hydrogen iodide are still occurring. Why do the concentrations of the reactants and products remain constant even though the forward and reverse reactions are still taking place? Answer: the reactants are being converted into products at exactly the same rate as the products are converted into reactants. The equilibrium is a dynamic equilibrium as the forward and reverse reactions are taking place at the same rate. Let us follow the rates of both the forward and reverse reactions of the reaction A gives B in a graphical form. If the reaction is started with A, then only the forward reaction can occur initially. As B is formed, the reverse reaction occurs. During the initial stages of the reaction, the rate of the forward reaction is greater than the rate of the reverse reaction. As the concentration of A decreases, the rate of the forward reaction also decreases. The rate of the reverse reaction now increases as the concentration of B increases. At point T, the rates of the two reactions become equal. The concentrations of A and B remain unchanged as a result. The reaction has reached a state of chemical equilibrium. The reaction between hydrogen and iodine that we have been looking at takes place in a closed system. A chemical equilibrium can never be established in an open system. Discuss and click Next. In an open system, the molecules can escape, and the reverse reaction will not be able to take place. For equilibrium to occur, neither reactants nor products can escape from the system. Summary: a chemical equilibrium is a condition in which the concentrations of all reactants and products in a closed system remain constant. A dynamic chemical equilibrium occurs when opposing reactions are proceeding at equal rates.